So like I said, I keep posting the samples on this code sample page, right? So we had our conversation about the model view controller architecture and this set of Java files we used in that experimentation earlier this week are being posted here on the samples page. Okay, so if you have any questions or issues with that, just email me and I will respond to that. So our agenda today is basically what I would like to do is to go to our first object-oriented paradigm type of lecture, which is posted on our outline, and this would be listed somewhere on week 2, which is roughly what we are having already, week 2. So let's take a look at this presentation and see what it's all about. So speaking of object-oriented paradigm, or in other words, a platform to build software, we're giving a lot of attention, a lot of focus to an object, right? So we just, I guess the idea behind this approach is that we can view world in terms of objects, and it's sort of easy to think about the world in terms of objects because objects encapsulate basically a state of things and things that these objects can do, right? For example, if you think about a heater in your house and a thermostat, which is usually a separate device, it's easy to think about these devices, physical devices, as objects, right? Because they both need some power supply, both need some sort of a control system, all kinds of sensors, but essentially they can be viewed as two objects that can cooperate, work together, interface with each other, send each other messages, respond to each other's messages, change their state. Like, for instance, a thermostat could create a connection to turn on the heater, keep measuring the temperatures. As the temperature goes up, as the heater warms up the air in the house, eventually the thermostat disconnects, and then the whole cycle will continue on, right? So it just makes sense to view such system from the standpoint of objects. Sometimes objects can represent not necessarily physical entities, but rather maybe contracts, such as, for instance, insurance policy or driver license, or other types of binding contracts that essentially involve multiple parties, but at the same time includes certain essential information about parties involved in these contracts. So these oftentimes legal binding contracts can be well represented by objects in software, right? So if you're modeling some sort of business which involves financial industry or insurance industry or banking or healthcare, lots of things such as policies, licenses, agreements, contracts will be present in that in that system. So they're not physical objects, they're basically legal documents, but they can well be represented in that regard. So we will say a lot about abstraction when working with object-oriented technologies, object-oriented programming languages, object-oriented design tools, principles, and so forth. Abstraction is almost an overused term in object-oriented technology because we rely on abstraction very heavily. What it means really is that when you're trying to build a system, perhaps an application system that wants to implement a set of tasks, solution to a number of tasks of a certain problem domain, a certain area, then it is highly unlikely that you will be able to model precisely the real world to all the details. Right? It's impossible. You need to simplify. You need to essentially disregard certain things which may not be making a lot of impact on what you're doing at one particular point in the life cycle of your system, but pay attention only to certain things. Basically, this is the mechanism of abstraction. You have to represent the real world in your simulation or whatever your application is doing by simply abstracting away things and giving things names which name things in real world, but they abstract away a lot of details. They simplify things. They give a slightly different picture, and yet when someone is using that system, it still makes sense, and they still see the information which is quite relevant to what the business is supposed to be doing, right? But if you're trying to simulate, a steam engine, you really don't have to bring every single detail of that steam engine into that software. You can essentially, simplify the function of the boiler in that steam engine. That's normal, right? You do not have to model every single piece of machinery of a certain mechanical device in order to represent it in software. It can be greatly simplified, just almost to the names of the parts that are making that a part of machinery, but still it can be well represented in a quite simplified form. So we call that abstraction. And that abstraction is that sometimes what we're trying to represent is simplified or abstracted. And abstraction has different forms. There's actually relationships involved there. We can derive things from one another and make things less abstract and more specialized or less specialized. So there are different levels of abstraction actually that is taking place in software. Next thing on this list is encapsulation and information hiding. So let me perhaps demonstrate this in a drawing.